Did you know it takes 33 engines firing simultaneously to lift the heaviest rocket ever built? SpaceX Starship stands 400 feet tall, weighs 11 million pounds fueled, and generates 16.7 million pounds of thrust. That's more power than the Saturn V that took humans to the moon. And Starship is designed to go much further. This isn't just another rocket. This is humanity's ticket to Mars, to becoming a multi-planetary species. The assembly process defies every rule of traditional aerospace manufacturing. Stay, I will show you exactly how. Building Starship requires solving an engineering puzzle that shouldn't be possible. It starts with raw steel rings. Each ring is 30 feet in diameter, machined to quarter-inch tolerances. Robotic welders seal every joint with blue arcs. Steam rises as the first super-heavy ring drops into position. This single piece weighs more than a fully loaded truck. Workers torque every bolt to exact specification. One loose fastener at this scale destroys months of work instantly. 3 sections stacked, and the booster is taking shape. 6 months from raw steel to a completed rocket stage. Overhead cranes lift 30-ton ring sections with precision measured in millimeters, watched continuously by laser sensors. The integration tower's hydraulic arms grip the growing booster, positioning it with accuracy that took years to engineer. The nearly complete super heavy booster stands 230 feet tall. The technicians at its base look like ants. Final structural welds seal the hull. The propellant tanks are complete. The manufacturing sprint is done. Now the Raptor engines arrive, the most advanced rocket engine ever mass-produced, at $2 million each. Acto 3, Instalación de Motor. Inside a Raptor, copper tubing, steel chambers, fuel injection ports finer than a human hair, controlled explosive power. Hydraulic platforms raise the first engine toward the booster's base as crews move with surgical precision. Every mounting bolt torqued to exact specification, because at 500,000 pounds of thrust, approximate kills missions. The first engine locks into position. Hydraulic rams secure the mount. 1 down, 32 to go. The clock is running. 6 engines form the outer ring. Advanced manufacturing ensures every engine meets identical specifications. No variation allowed. Color-coded fuel lines connect each engine to the propellant system. This supply chain spans 12 countries. Electrical connections are made for sensor arrays that will capture 50 gigabytes of data per 30-second test. The inner ring of 13 engines is lowered by synchronized cranes, a choreography that took months to perfect. Each gimbal calibrated with hydraulic micro-movements. Every Raptor pivots to steer 5,000 tons, 20 times per second. White vapor billows as cryogenic lines are pressure tested at -300 degrees, just inches from the crew. 19 engines installed, 14 more to go. 39 engines means 39 potential failure points. Quality control is everything. The 33 Raptors must fire as one synchronized system, the tightest engine formation in aerospace history. The 33rd and final engine bolted into position. No ceremony, no announcement, just the next task on the list. From above, the engine bay shows perfect geometry. 33 Raptors in concentric rings. The booster has its teeth. Acto 4. Integración. Ship integration demands millimeter precision. The Starship upper stage is lifted by the integration tower's mechanical arms. The ship's heat shield tiles gleam silver, hundreds of hexagonal panels, each protecting the crew from 3,000-degree re-entry. The ship descends toward the booster as the 2 massive structures meet at the top of the integration tower. Structural connection points engage. Engineers mate ship to booster. 400 feet of controlled chaos becomes one machine. The full stack towers against storm clouds over the Gulf Coast, taller than a 40-story building. Integration complete. Fueling begins. Cryogenic lines connect between stages, white vapor streaming as the super-cold propellants start to flow. Liquid methane flows at -260 degrees Fahrenheit, 4.6 million pounds of propellant, more than any rocket in history. Pressure gauges climb as thousands of tons move through the feed lines. Too fast, and thermal shock cracks the steel. Liquid oxygen cascades down the rocket's sides at -297 degrees. The tanks are filling. The rocket is waking up. The fuel farm holds massive tanks connected by thick umbilicals. Enough energy here to power a small city. Automated systems monitor pressure, temperature, and flow rate simultaneously. One sensor failure aborts everything. Steam and vapor create an otherworldly atmosphere as temperatures around the rocket drop 200 degrees in minutes. Ice crystals form on the external lines as propellants reach operating temperature. The machine is becoming something alive. The control room tracks 400 individual parameters simultaneously. Fueling complete. The countdown is no longer a concept. Orange flames from flare stacks safely burn off excess methane. Even the waste product requires its own engineering solution. Acto 5's pre-dawn darkness, the fully fueled rocket and vapor clouds. Static fire testing proves the engines won't destroy themselves. Pre-burner systems glow red-hot as the ignition sequence initializes. Automated systems take over. No human can override what comes next. Fuel injectors open with microsecond precision, methane and oxygen mixing in combustion chambers. The sequence is irreversible. Blue methane flames appear at the nozzles as controlled ignition spreads across the cluster in precisely designed sequence. All 33 engines ignite simultaneously. The roar drowns out jet aircraft. Exhaust temperatures reach 6,000 degrees, hot enough to melt copper. Acoustic shockwaves ripple across the landscape as cameras shake. 16 million pounds of thrust held in place by the launch mount. Molten concrete flies as exhaust carves channels through reinforced steel. Sound levels hit 180 decibels. The deluge system activates. 500,000 gallons flood the launch mount in seconds. Steam explosions visible from 20 miles. This is the price of power. 33 engines adjust 20 times per second as thrust vector control systems balance 16 million pounds of force perfectly. Test duration, 30 seconds, enough to validate performance. Engineers analyze every millisecond, 50 gigabytes captured in half a minute. Controlled shutdown, flames extinguish in sequence, static fire complete, launch readiness achieved. The data is everything now. Integration tower arms extend as inspection begins. Engineers will spend weeks processing every parameter from this test. Sensor streams confirm it. Every engine performed nominally. Full-stack testing validates years of engineering dreams. Acto 6, technicians inspect all 33 engines by hand and instrument. Every component proven. Every system ready for the real launch. Heat discoloration on the nozzles tells engineers exactly how each combustion event performed. Data improving every future flight. The rocket rotates to vertical as sensors monitor structural loads, vibration patterns, and thermal expansion throughout. Structural load points bear the full weight of the complete stack. The rocket that will carry humans to Mars sits ready. This isn't just testing hardware. This is testing the future of human civilization. Cost efficiency through reusability. Proven. The complete stack stands on the launch mount, umbilicals connected, systems live. Advanced manufacturing proven at scale. Green lights across every engine control panel, system after system confirming nominal. The impossible has been made routine. Launch commit criteria met. 400 pre-launch checks complete. Ignition command transmitted. There is no going back. Anzamia zone. Orange sunrise silhouettes the tower as final countdown preparations conclude. History is either made now or the mission scrubs. Propellant loading arms retract. The rocket becomes an independent vehicle, carrying its own fire toward the stars. Final cryogenic loading complete. Steam everywhere, ignition sequence initiated, every weld, every bolt, every line of code. Pre-burner flames appear at the engine bells. Methane and oxygen meeting in the chambers for the last time on Earth. 33 engines roar to life. Exhaust plume blinds cameras, sound waves shatter windows miles away. 400 feet of steel and dreams rises. Hold down clamps release, physics bends to human will. Starship climbs toward space, toward Mars, toward forever. Acoustic shockwaves shatter across miles of coastline. The rocket climbs through its own exhaust, gaining altitude and velocity. The atmosphere thins. The trajectory curves toward orbit. The machine does exactly what it was built and paid to do. Thrust vector control steering 5,000 tons, 33 gimbals adjusting 20 times per second. Precision of surgery, power of a star. Supersonic, the rocket crosses the sound barrier and continues climbing. Beautiful, unstoppable, exactly as designed. Structural separation systems activate at 70 kilometers altitude. Ship and booster about to become two separate vehicles. Explosive bolts fire, clean separation. The ship heads to orbit while the booster flips and begins coming home. Super heavy reignites for the boost back burn. No other rocket has executed this maneuver at this scale, until now. Both vehicles in flight simultaneously. Ship ascending to orbit, booster descending under powered control. Two missions as one. The booster's landing legs deploy as the 230-foot cylinder prepares for precision touchdown, the most complex self-landing object ever. Touchdown, vertical. Engines still burning as the booster settles onto the pad. What was called impossible, made routine. It will fly again. The next industrial revolution isn't happening in factories on Earth. It's happening in orbit. Al9, orbital. The ship reaches orbital velocity. Earth curves below, a pale blue arc against infinite dark. One species, two worlds now. Cargo bay doors open, payload capacity that dwarfs anything ever launched. This is infrastructure for a multi-planetary civilization. Multiple starships in orbit, deploying cargo across the solar system. The space economy that was once a concept, becoming real. If starships succeed, what's next?